If not, kindly notify me on the questions tab. I will respond to you and tell you how to change the settings. We will begin in just 2 minutes. We're waiting for the other attendees to arrive. Okay, we will begin today's session. First of all, I thank you all for attending today. I know it's been a very busy day for you. Thank you for taking out time today. Good morning and a warm welcome to all of you. I am Karan Taneja from the International Business Team at Midas IT, and I will be conducting today's session on RC building design using Midas Gen and Design Plus. So, firstly, if you are facing any problem with the settings, kindly check the highlighted tab on your window. You can select the setting and you can see whether or not. Yes, sir, we will record the webinar and we'll send it to you for, you can view it with the other members of your staff as well. We'll send it to you at the end of today's session. So during the presentation, your mic will be muted, and if you have any questions, please just type them in the questions tab and I will answer them as soon as I can. So if it's all okay, then I'll begin the session. You can type the questions here. So let's begin with today's session. Firstly, an introduction to Midas IT. For those of you who have not heard about it, Midas IT is one of the world's leading CAE solution providers with our headquarters based in South Korea. We provide total solutions for not only civil engineering, but for also buildings, geotechnical, as well as mechanical engineering. Flagship products in those areas can be seen on your screen, such as Midas Gen, which I will be showing to you today, which is for buildings and general structures. Midas Civil is also one of our most popular products for bridges and civil structures. Midas GTS is for geotechnical and tunnel engineering. And Midas NFX is for mechanical engineering works. So if you are interested in any of the above programs, you can visit our website and look forward to future webinars, and you can download the trial as well as tutorials and technical documents from the website. So the objective of today's session is firstly to introduce Midas Gen to you. Then I will model an RC structure using Midas Gen. and I will introduce Midas Design Plus to you, and I will perform a short demonstration of how to design a structure using Midas Design Plus. Then we can have a question and answer session, and we'll conclude today's webinar. So now, why do we at Midas think that what we offer will be of great use to you? Because Midas Gen and Design Plus combined together increase the overall productivity and the efficiency in performing day-to-day engineering tasks. How and why, it will be clear to you towards the end of this session. First off, an introduction to Midas Gen. Midas Gen is a general purpose structural analysis, not software, not for only buildings, but also for other structures like plants, stadiums, specialty structures, and these are some of the most major projects we have in which Midas Gen was used. You must recognize the Burj Dubai from there. In the Guangzhou Twin Towers it was used. It was also used in Vietnam as well as in the Moscow City Palace in Russia. Now the plant structures also were designed using Midas Gen, for example in Iran, here in Korea as well as in China. This has been used quite widely in India as well. As I was mentioning before, Midas Gen is a very versatile software. You can see on your screen shortly that we not only design buildings, but also we design specialty structures like stadiums, as in the Beijing Olympic Stadium. You must recognize the bird's nest here. You can also design airports. This was used for some of the features for designing the Beijing International Airport, as well as the Incheon International Airport here in Korea. We also use the Midas Gen in China as well as in the Foshan Stadium. Also, we have a special feature for masonry analysis, like it was used in this villa in Italy, the Tempietto de Via Barbaro. It was used for rehabilitation works in Italy, and it's quite popular there. So now I'll give you a short intro on what our basic user interface is like for Midas Gen. Now, Midas Gen provides you various menu systems and windows for the user-friendly workspace. In addition, it provides supplemental windows such as the tree window. You will see that here. On the left side of your screen, we have the works tree, which is quite useful, and the use of this I will show you in the demonstration. The main menu, whereas you can change all the parameters, you can include the elements and the tab toolbars, which will give you shortcuts once you are used to the program. So moving on. Now, file manipulation is very crucial these days since various engineers work with various softwares, and Midas Gen can fully handle the file manipulation. We have a direct data transfer with Tekla and Revit structures, and also you can import STAAD and AutoCAD DXF files as well as MSc Nastran and SAP 2000 file as well. So to give you a look at how it looks like, I will go to the program and I will give you a brief intro on how you can import a, let's say, a CAD file. So on your screen shortly, we'll see the look of the program. This is how Midas Gen looks like. I'll go to File, go to Import, and here you can see you can import an AutoCAD DXF file. Just need to go to Browse. This is the DXF file I'll be importing. And you can define the material in this section later on as well. So when I click on OK, you will see shortly on your screens So currently we do not have that feature. In the future, like let's say versions for the, let's say we'll update Midas Gen in December. We can look forward to that feature. Maybe we'll include that in that feature, in that version. So as you can see on your screen, this is the model we have imported from AutoCAD. You can zoom in and see what the structure looks like. So you can see how the complete design file has been imported without any major obstructions to the Midas Gen. So heading back to the program, I'll show you a little bit more about Midas Gen. So also in a complex project, let's say you're not alone working, you work with a lot of engineers. So, and a number of engineers working on one project, you have difficulties in merging all those files. So Midas Gen has a special feature for that. We can merge individual files to form one analysis file. Like let's say you can text the input commands using the MGT command shell, and the entire data will be merged into one model. You can see like on your screens on the bottom right corner, these three models are being used by three engineers, and using this feature, we combine these three models to form one analysis model. Midas Gen also provides you with a very vast material database, and good thing here is, since engineers are very creative people, we need new materials all the time. So user-defined materials can also be specified. We include most of the international database, such as the British codes, the American codes, the European codes, and some of the codes used in other countries as well. And we are continuously adding more and more database for each update. Same goes for the section. In the sections property, you can define sections using codes from America, Europe, Canada, and Asia. We include a section database that contains I sections, T sections, channels, angle, pipe, and so on. You can also create your own user-defined section, since most of the time engineers use their own sections in their models. Not to worry, we have a feature called General Section Designer, in which the engineer can create their own 2D section, and in turn the program will consider it as a prismatic section, and then the engineer can continue with the modeling. Now, to reduce time, we have a feature called structural wizards. In order to reduce the modeling time for the user for a typical shape of the model, let's say you want to create an arch, we have a wizard frame for that. And using that, you can create unit structures such as a frame, an arch, a truss, a plate, and a shell can be very easily modeled, and you can greatly reduce your time. Story generation. Now, to create a multi-story building, you need to model the slabs as well, and that can be done in two ways. Firstly, the slab can be modeled using plate elements, and secondly, it can be modeled, you can not exclude the slab, but you can consider it as a rigid diaphragm. Now, rigid floor diaphragm can be easily considered without actually adding the slab in the model, and the mass data, which is automatically entered at the diaphragm centers, that is the center of mass, is auto-calculated for each story. Now, the auto mesh feature is also available in Midas Gen. This is useful for slab and wall design. Midas Gen automatically meshes the selected slab or the wall element, and even the corners are meshed with great accuracy. It automatically adjusts the size of the mesh, and using this feature you can also model caissons, pumping plants, arch tubes, and the underground subway stations can easily be analyzed using this feature. Now, moving on. Midas Gen also enables you to specify all types of nodal, element, point, surface, dynamic, pre-stressing, and thermal loads encountered in practice. You can see on the right side of your screen, these are some of the loads that are available in Midas Gen. And you can also input time history loads, and you can also input static, wind, and seismic loads. We also have provisions for dynamic analysis, like in the dynamic nodal loads, and we also have provisions for construction stage. Now, since static wind and seismic loads are quite important when it comes to multi-story structures, I'll be just showing you a small slide on them. Now, Midas Gen generates static wind and seismic loads on a building structure for each story, and all one has to do is to provide the applicable standard. Like for wind load, we have IBC, the UBC, the ANSI, the Euro code, British codes, Indian codes, and the local Japanese, Taiwanese, and Korean codes as well. For seismic load, we have all of these codes except the BS, and in future versions of this, you can go and look forward to that being included. You can also import static wind and seismic load on flexible floors. Now, seismic analysis can also be handled by the program. We have provisions for dynamic analysis, like you can input a response spectrum on your structure, and you can also input a time history load. This can be quite useful when it comes to checking the floor vibration. You can check for the heel drop, and it will give you the frequency as well as the displaced contour of how your floor is behaving. Now, in order to create a realistic model, it is necessary to give proper boundary conditions to the model. Midas Gen, our software, it supports various types of boundary conditions, such as we have point spring supports apart from the general supports. We have surface spring supports. We can also model pile springs and elastic links, rigid links, and beam end releases as well as beam end offsets can be modeled in Midas Gen. Now, coming to the soil interaction. Now, this is very important when it comes to the basic footing and the foundation analysis. We can model soil as multilinear springs to take care of the soil stiffness, and the non-linear characteristics of the spring over the pile height are automatically calculated. So when you get the displacement, you can easily calculate the forces and the stresses developing. Now, on your screen shortly will come a list of the analysis types we have in Midas Gen. Midas Gen supports all kinds of static analysis, and we also have features for dynamic analysis, as I mentioned to you before, like free vibration, time history. We also have features for geometrical nonlinear analysis, such as the P delta and the large displacement analysis. Also, we have provisions for heat of hydration and construction stage analysis, and pushover analysis can also be done using Midas Gen. Now, when it comes to results, we are very flexible with how you can show the output of the results. We have them available in tabular formats, and these are very compatible with Excel. We provide spreadsheets for all analysis and design results, and you can also filter the type of results you want. You can also modify the table there itself. You need not take it back to Excel, and even if you want to use it for your report, you can copy this table to Excel. Now, Midas Gen also offers results of stories, like multi-story buildings, in a tabular form which are compatible with Excel. Now, a special feature for multi-story buildings which we have is you can define modules for a twin tower to check for the results shown on your screen. Like suppose you have this model on the bottom right corner of your screen, in which we have two towers. So you can create a module for the first tower, the second tower, as well as the foundation. And for each of these modules, you can get separate results for the mentioned data sets. We also have a feature for dynamic report generation, in which, let's say you want to create a report in a short amount of time. Midas Gen will create a report in the MS Word format. What you need to do is you just need to enter the information for the first time, and then for the second time you open this function, Midas Gen will automatically input the data for you, and you just need to print it and present it to your superiors. You can also drag and drop the images from the results and the design features, and you can also copy the table format into the report. Now, the design features in Midas Gen are quite extensive. Like for RC designs, we have design features for American codes, for the Euro codes. We also have provisions for slab design, in which you can model and design slabs in one single software, that is in Midas Gen itself. You need not transfer your model to another software to design the slab. You can design flat slabs under the ACI as well as the Euro code. We also have provisions for steel design, for composite beams in the SRC, and we also have design for footings. As I mentioned before, Midas Gen also supports mesh, slab, and wall design apart from its analysis features. Shortly on your screen you will see the slide. We have mesh slab designs as per plate elements for the American and the Euro codes, and you can design for non-orthogonal reinforcement directions based on the wood armor formula. Now I will show you a live modeling demonstration on how we model our building in Midas Gen. Firstly, we will model it, then we will introduce the load cases as well as the response spectrum, and after the analysis, we will show you a basic design of how Midas Gen does it. So I'll go to cancel and we'll select a new file. So firstly, what you need to do is to create a frame. I'll show you the application of the wizard here. Let's say we create a 6 meter, we repeat it at 4, 6 and 4. This will give you a basic introduction of how your frame looks like. Here in the edit tab, when you go to, you can enter the material as well as the section properties. So as I mentioned to you in the presentation also, we have a material tab where you can select what kind of material you want. I'll go for concrete. Let's say I select the ASTM code, and in the database, whatever types of concrete material are available, Midas Gen will provide it for you. So give a name, concrete. Click on OK, and your material has been created. Similarly, you can go for sections. This is the section tab. You can select what kind of a beam you want. So I go for solid rectangle. You can see we have provisions for combined, tapered as well as composite sections. So I go for the user. Say I give a beam a dimension of 0.55 by let's say 600 millimeters. Click on OK. And then for the column, same, but I just need to change the dimension and go for 0.7, right? 0.7. So clicking on OK will create both my sections. Go to close. I'm selecting it from here. This will generate our basic frame. So now I need to define the insertion point. I will go for a height of 3.5 meters. And since the frame was being created in the XZ plane, I will rotate it to the XY plane, and clicking on OK, you will see on your screen how the basic frame has been created. So this is how the basic frame will look like. Now all we need to do is to extrude the column. Yeah, so you will see on your screen right now that we have our frame in front of us. So going to the element, you go to extrude, go to column, and now we need to select all the nodes. So for that we have a feature called select all, but here you will notice that we have all our elements as well. Not to worry, in this tab you can singularly select or unselect all the elements. So I simply deleted the elements from here, and now I only have the selected nodes. So what I need to do now is to enter the column height, go to minus 3.5, clicking on apply, this will give me my columns. You can see on your screen that the columns have been created. Now all I need to do now is to create shear walls and then assign the boundary conditions for this frame. So I will go ahead with the shear wall. I go to planar. And now I'll select the wall element. Now for a wall element, I need to enter the thickness of my section. So I need to go to add. Say I will give a section of 0.45. Click on OK. Now the section is here. All I need to do right now is just to select the area where my shear wall will be. So for that we have a feature. You can singularly select the beam. So now since the beams have been selected, I will let the shear wall be of the same height as the column. And clicking on apply, you will see on your screen that the shear wall has been created. Now I need to assign the boundary conditions. So going to model, boundaries, and now you can see on your screen that these are the types of support conditions, the boundary conditions that we have. I will be going to supports, and I will provide a fixed support for all the nodes. Now for selecting the bottom nodes, you can do it in this way. go to the front view. We have the option for selecting by window. Now when I drag and drop the window from one end to the other, we'll see that only the nodes have been selected at the bottom. I will rotate the structure for you to view it. The buttons in the purple are the selected nodes. So now we'll assign the boundary conditions by clicking on apply, and now the boundary conditions have been applied. So now Midas Gen has a feature. Let's say you want to change the section midway to your model. So let's say you remember you had a section from your previous model. All you need to do now is go to model, properties, go to material, and now I will import a section from my previous, let's say I want to go for the model I use in my trial structure. So you will see that all the sections from that have been imported here. I will select only the section I want, and when I click on OK, these new sections will be added. Now when I want to add them to my current model, all I need to do is select. If you double click, all these models will be selected, and I can just drag and drop this property on the model, and now you will see that the model has been updated with the latest section. Same for columns. You can see that the columns have also been updated. So going back to the modeling process. Now since our basic frame has been created, what we need to now do is to generate our building. You don't need to copy and paste and do all that stuff. We have a feature called building generation. So here you need to mention the number of copies you want for each section. Go to 9. Give the distance. Let's say I want to give a story height of 3.5. Sorry. Go to add. And here we need to be careful of one thing. We don't need to copy the supports. So when you go to copy node attributes, click on the others tab here, and you deselect all the supports, since you don't want your fixed support to be at every story. By clicking on OK, now I will select the entire structure from the select all function. We also have keyboard shortcuts for these functions, like when you press Control Shift A, all the entire structure will be selected. So by clicking on apply, you can see that within a second your entire model has been created. So this is how your building, basic building looks like. So now we need to apply the load cases. To do that, right click, go to load, and select the static load case option. So here we can enter the dead load, and we have many number of load cases available, like the dead load and the live load, which are the basics, and going on to the advanced loads, such as the construction stage load, the centrifugal force, the explosion loads, and the earth pressure, rain load, snow load, and a variety of load cases. So we select dead load, we select live load, go to add, and then you can also add wind load from here. Go to add, and since we're doing it for both the directions, the X and the Y, add, as well as for the earthquake loads. We'll model the earthquake load on this building. So I'll model it for X and for the Y direction as well. So after doing this, I'll directly go on to the already analyzed model. This structure is almost the same structure that we modeled in the previous minutes. So as I mentioned, the works tree gives you a complete summary of how and when you made your changes and what kind of changes you made. Like this will show you the amount of sections, the materials, as well as the shear wall elements and the load cases, as well as the response spectrum, analysis functions which we have. So moving on. To assign load cases, what you need to do is to, let's say for self-weight, go to load, go to self-weight and enter a -1 value here. Clicking on add will directly apply the self-weight to the structure. To assign flow loads, you can normally assign beam loads and element beam loads. Going to load, right clicking, and from here you can assign the element beam loads. To define flow load types, the slabs can be modeled in let's say 2 ways. You can either model them as plate elements or in the form of a rigid diaphragm. I'll show you shortly. The results will be almost the same, but I'm currently not modeling slab. If you want, I can hold a special webinar training session for you, and we can go on with that topic. So going on to the load tab, we have the define flow load type. So here, the advantage of this function is that you just need to enter the name and the amount of load you are applying to each floor on this tab, and by clicking on add, when I go to the load tab and assign the flow loads, you don't need to enter the data for each floor at almost every location. You have your load cases made for you. Just select the load case you want, enter the node number, and you can also copy the flow load. Let's say if I want to assign the flow loads from this floor to the ground floor. So I just need to enter the load, let's say here. Then I can copy the entire load to the structure below, or you can do that vice versa also. And you can also model separate load cases for the roof. You select any of these, you can model the separate load case for the roof. So after the flow loads come the wind loads. To assign wind loads, you need to go to load, go to lateral loads, and here you will see we have wind load as well as the static seismic load. So I go to wind load and I click on add. This is the tab that will open in front of me. You can enter the load case name from here, select it, select the type of wind load you want to check with which code. As I mentioned to you in the presentation, we have these kind of codes available. And you can select whether you want the alternate method or the direct procedure method in the American codes. Enter the parameters as per your choice. It depends on you whether or not you want to give the wind eccentricity. And for the direction, you can give a scale factor. Since we are modeling only for the x direction, I will give a scale factor of 0 for y. And clicking on add, you can see that at the bottom in this table, it will show you how much we can give assigning the loads. And by clicking on wind load profile, this will give you an approximate view of how the wind loads are being applied, the story force, story shear, as well as the overturning moment. So it will give you this in the tabular format as well. Now this is also compatible with, let's say you want to, So to make a wind load calculation sheet, you can click on this option and it will create a calculation sheet in the form of a text editor. You can copy that to Excel and to, let's say, Word also. Now we can do that for the X as well as for the Y direction. So when I close this, same can be done here. You just need to change the scale factor, and maybe if you want to, depending on the topography of your model, you can change the scale factor. We're keeping it at 1 at this moment. To amount for the earthquake loads, right click, go to load, and when you go to lateral loads, you will see an option called static seismic loads. By clicking on this, these are the load cases that I already made. So when I go to add, you'll see that this is, I just need to select the load case, enter the code I want to check my model with, and then enter the spectral parameters. To calculate the approximate period, we have 5 to 6 formulas, and you just need to click on OK, and Midas Gen will automatically calculate the approximate period. So here also you can change the, let's say I'll change it to 0. since this is in the X direction, I give an eccentricity. I don't want to give an eccentricity. And I select the story, even OK. And this is how my seismic load profile will look like. You can see on your screen that the story force, the story shear, as well as the overturning moment in a graphic as well as in a tabular format are provided to you. By clicking on close, since the load cases are already made, the same happens in the Y direction. We just need to change the scale factor from 0 to 1. Going on to close. And what's left now is a response spectrum. So to model the response spectrum, there are two ways of doing this. Go to load, response spectrum analysis data, select the type of function you want. So when I click on add, you can design the spectrum. You will see on your screen right now. I click on design spectrum and this tab will open in front of me. So I just need to change the parameters according to my choice. You can also vary the maximum period. And after this is done, clicking on OK will create a section. So I'll show you the section and the function I already made. This is how it looks like. So this also gives you a graphical view of the spectral data versus the period we have for the model. You can change the G also if you want to, but that depends on the engineer. Now to assign the response spectrum, right click, go to load. Going back to this data, we have response spectrum load cases. So I need to go back to the presentation to introduce a feature we have. Now response spectrum loads depend basically on the principal axis. So the principal axis, what is the principal axis? It is, in the engineer's language, it is the direction in which the seismic load has the largest influence on the structure. Now for regular structures, like for the plan shown to you on your screen, it is very easy. You just need to, this is by, let's say by naked eye you can find out what the principal axis, what the angle of the principal axis will be. Now if it is an irregular structure, like for this structure, engineers generally calculate the, on your screen you show you the plan of the irregular structure. So engineers generally calculate the principal axis using, let's say, what I know, the graph that they make. We check for an iterative analysis, you check for various angles, plot a graph, and where the dip occurs, that is where you assign the principal axis. Midas Gen automatically finds out that angle for you. All you need to do is to select the auto search angle. You will see on your screen the highlighted red box, and I'll show you just now how you can use it. You just need to select in which direction you want to check for, like in the major direction, like in the X, or in the ortho direction, and Midas Gen will automatically calculate the excitation angle for you. So going back to the program, so when I clicked on went to load, and I went to the response spectrum analysis data and the response spectrum load case, this tab will open on the right side of your, on the left side of your screen. So I need to enter the name, select the direction, let's say for X, Y, or for Z. Now since this is a very regular plan, I don't need to select this feature. I give an excitation angle of 0, and I need to select the spectral function, the function I just created, and you can enter the scale factor, and from here you can enter the number of frequencies you want to see, the number of mode shapes you want to see in your structure. I've kept it at 15, 15. So by clicking on add, this load case will be created. Same for the Y, I just need to change the load case, change the factor, and my response spectrum case will be allotted. Now, after the analysis, this is the analysis button. You can see on the cursor, this is the perform analysis button. There's a shortcut also. You can press F5 or you can go directly to analysis and then go on to perform analysis. The mode I was showing you currently was the pre-processor mode. Since this is an already analyzed model, I will now be showing you the post-processing mode. So after this is done, I will show you some of the results that we have. Firstly, we need to create the load combinations. So you can either go to General or to Concrete Design, go to the Results tab, and by clicking on Load Combinations, Midas Gen can automatically generate the load combinations for you. I apologize because you can't see the bottom of the screen due to this. So this is how the tab will look like. By clicking on Auto Generate, so this is how the tab will look like. You just need to select the design code and give scale factors for the RX. So I'll give 1.3 in the X direction, 1.4. So when I click on enter, these load cases will be generated. You can see, you can also find out the factor of safety applied to each load here. And you can see this in a spreadsheet format as well. It creates load cases for all the strength and the serviceability criteria mentioned in the preferred code according to your choice. So going to close. Now I will show you the results feature we have beginning from the bending moment diagram. So let's say I want to check the bending moment available for one B. So this is the general bending moment diagram, and I want to specifically examine. So on your screen right now you will see how the bending moment diagram for just the dead load cases in the model. If I just want to see the bending moment for one element, let's say I want to see for the beam number 881. I go to Quick View, click on this tab, and this dialog box will open. So here I can select the beam element. I selected number 881, and this will show me the bending moment diagram for this load case. Let's say I want to check for EY or EZ. Let's say I check for the wind load in the X direction. So when I move my cursor at each of these locations, Midas Gen will provide me with the bending moment values at the I end, the J end, and it will also give me a comparison between the maximum and the minimum values. So I'll show you some of the other results also. Going to the beam detail analysis. Now this is an advanced version of what I just showed to you. So this is how the beam detail analysis will look like. I just went to the result tab and selected the beam detail analysis option. I will select the load case I want. Let's say I want to see for my EY how the structure behaved. So I will click on apply and I will select the element number I want to see. Okay, I'll change the model to this. So this is the same model, and I was on the results tab, so I go to results. Going back to beam data analysis, I select the element number, and now this will show me the maximum displacement, the shear force, as well as how my bending moment is varying at each section. So here I just need to move my cursor, and let's say at each section I want to see what the shear force is like. I just need to select the section, and that will be done. Going to close, and very quickly I'll go on to the story results. We have results in tabular format for stories, like for story drift, story displacement, for torsional irregularity checks. I'll be showing you the story shear force ratio, just to give you a basic idea of how it looks like. So I'll select the wind load and the earthquake loads, and I will just select, let's say, 3, 4, and 5. By clicking on OK. So as you can see on your screen, this will show me how much shear force is my wall and my beam carrying. And when I go further down, this will give me even a ratio of at each floor, what is the ratio of shear stress carried by the wall and the beam. You can see on your screens right now. So this is the ratio. Now I'll just give you, Midas Gen also does basic design for beams and columns. So you just need to assign the codes, select the code, and clicking on OK will give you the code. Will give you the preferred code for design. I go to concrete code design, and let's say I select this beam and this beam for my design features. So I go to design, go to concrete code design, beam design, and this will show me either by member or by the property of how my beams are, if they're okay or not. Midas Gen will give you a detailed report. Okay, I'll select a section for you and give me a detailed report in the text editor format. You give me the load cases as well as, just need to select them on the detail. Give me the load cases, and it will give me the hand calculations as well as the verification features. So when I go further down, now here it is on your screen. So this is the detailed report from the beam design. This is how it looks like. The hand calculations are at the bottom, and this can be directly copied to a Word format and given to your superiors for the reports. You can also copy the entire table if you want to. We can also do column design. So I'll select the columns, and let's say go here. We'll do the column design. So expanding this table, we can also get a 3D PM curve, PM interaction curve for a model. So in a 3D format, it will show you how the PM curve can be modeled. Go to close. Now, same as in the beam, Midas Gen can provide you with a detailed report for the column as well. You can also design for walls. You can also design for wall. Like I haven't selected the wall element right now, so this is how it does. You just select the element, and by clicking on wall design, Midas Gen will give you the PM interaction curve as well as a detailed report on how the hand calculations were done, and this can be used in the verification features. So now we go back to the basic point of why we think you need Design Plus. So I'll resume the slideshow. Now this is how the design process actually looks like. Shortly on your screens you will see. Yeah. So firstly, you need to create the architectural drawings. Then you need to model them in the software the analysis, then the result sorting. Then comes the tedious part of structural design. Now, for that, you first need to design this using the software. Then you need to copy the results to Excel, use the another software for design, then use Excel again, and since creates a very, very long time. So to escape that thing, Midas IT has come up with a new product, and it makes for a very easy and fast design process when combined with Midas Gen. So it is Midas IT's focus is always to reduce the engineer's workload. So hence that is why we came up with this program, and Midas Gen is one of those solutions developed to increase the efficiency and the productivity of the engineer. Now, 5 reasons of why we think you need Design Plus. Firstly, it is very easy and fast to use, as I'll show you very shortly. It has a very good interface with Midas Gen. The use of that will also be shown to you. It has auto drafting and editing functionalities. That means we can create CAD drawings as well as you can create member reports in the Word format and also the Excel format. We have accurate calculation results as proved by the verifications, and we give very high quality output and results in the form of Word as well as Excel. So these are the modules available in Design Plus. The RC module contains slab, beam, column, and the steel module contains the beam and column design as well as the base plate, and we also have features for composite beam designs. So I'll go to the program. So this is the basic interface of what Midas Design Plus looks like. To create a link between Gen and Midas Design Plus, you need to go to Link, go to Midas Link, and then I'll just select the structure. You can see as the sign turns green, that means your structure has been linked with Design Plus. Now the use of this, I'll show you. Going back to our model. Okay, firstly I'll show you how the slab design is done. You need to enter the concrete, the rebar, and to assign the load, all you need to do is to create a load case. Say I give floor 1, and as per the selected code, the load factor will automatically be updated. Floor A, and I give a load of say 5.5, and here the type of live load can be automatically calculated by Design Plus. Just need to select the type of live load among the various facilities available, and when you click on calculate, according to the code, Midas Design Plus will automatically input the service and the factor of safety. So when I click on add and clicking on apply will apply this on the slab, I just need to select it. So as you can see, the loads have been inputted, and if you need to select a two-way slab or a one-way slab, that depends entirely on the engineer. I go for a fixed supports. So clicking on design, and Midas Gen very quickly shows you whether your slab design is okay or not. Now Midas Design Plus has 3 modes. The first one being the check mode, second one being the simple mode. The simple mode is what you're seeing right now, and the project mode gives you a variety of other options. So I'll go to the project mode, and you can see there's a variety of inputs that you can edit. First being the type of bar arrangement you want. For the first arrangement, we have this kind of variation in the reinforcement detailing. For type B, we have this kind of variation, and for type C, we have just 2 continuous bars as the reinforcement. So I'll select type A, and when I click on design, I'll select the rebar I want, and clicking on OK will give me whether my design is okay or not. Now the main headache, let's say, of an engineer is how to create a report. Not to worry. Go to report, clicking on detail, will generate a Word formatted report for you. We'll see shortly on your screen. So you just need to enter the name of your company, and this report contains the material, the design load, the section size, even the reinforcement diagram. And scrolling down, you will see that it also gives you a check for the loads, for the thickness criteria, whether it is satisfying the moment and the shear capacity or not. So going back to the other features, so I will now show you how we design a beam. So I'll select the beam I want. I go back to the program. So I'll select the beam. 2, 3, 4, 5. So when I go back to Design Plus, I go to the beam option, and you will see that all the beams that I selected in my Gen have been imported directly to Design Plus. Now this saves the engineer a lot of time, since what actually happens is you need to enter all the data into an Excel sheet, and then you need to transfer it to the other programs. We simply just linked our Design Plus to Gen, and you will see now that where my cursor is pointing, the moment the shear have been automatically inputted each at the respective section. So this will save the engineer a lot of time, as well as a rebar arrangement. You can change it from here if you want. If you want to modify, you can go to here and select from the provided rebar sizes. You can select from here by clicking on Design. Midas Gen will give you whether your design is okay or not, and also give you a graphic view of how the reinforcement will look like. Now since I selected two types of sections, here two types of beam are created. Like so two types of sections were created, and if my model contained, let's say, 300 types of beams, you can even import 300 types of beams into Design Plus, and you can design each of them. So going to other features of Design Plus, if let's say you had multiple number of beams, you can get them in the Excel, let's say a tabular format, and this complete thing is compatible with my Excel. So if you want to copy, you just can select from here and copy it to Excel, and then if you want to use just this for your report, you can use this. So you can also do the design from here. You can change the inputs. So if I want to change, I'll change it from here. And designing it can also be done here. See, all the checks have been applied. Now the other feature which we had was the drawing. So I go to Create. Since there were two types of sections, Midas Design Plus has given me two types of CAD drawings. When I went to the Drawing tab, I just clicked on Create, and this appeared before me. So one interesting thing here is this is completely compatible with all CAD commands. Let's say you want to zoom in. So I just need to select the window, and you can zoom in. And if you want to create line or input anything on these drawings, these are the final engineering drawings that you have for your beam sections. So you can directly give them to the draftsman. So this is how the CAD drawing will look like, with all the bar as well as the detailing definitions. Now we go to the column. So I'll head back to Design Plus. This process is much easier than copying all your results to Excel and then going to other software. So you just need to select the column. So I'll just do that. So I'll head back to Design Plus. When I go to column, I just need to click on import. You can see that since I designed it in Midas Gen, all the axial forces, the shear force as well as the moment have been inputted to Design Plus. You just need to design it. If you want to change the reinforcement, you can do that from here. I will be keeping it the same. So clicking on Design, Midas. So currently we do not have that feature, but in the next update that will come in December, we will have that feature. We can use. In the meantime, only what we have right now is the section design. So it gives you the PM interaction curve for the columns, and you can also see whether it is satisfying the moment capacity or not. If it is not, it will come in a bold red format that it's like an NG will be written here, and it will show you the amount by which it is exceeding or which it is less than the desired value. Then also amount for splicing of rebars. Now I've shown you the member list, the drawing as well as the quantity, as well as the drawing, sorry. What I need to show you now is the quantity. One good feature we have in Midas Design Plus is it can calculate the amount of concrete as well as the amount of reinforcement you need. So you just need to select, since I had two columns, I just clicked on create, and for each of the column sections it will give me the amount of concrete as well as the amount of reinforcement required. So going on to shear wall. Now column general is just for the irregular shaped columns. Since we don't have that in our structure right now, we won't use this function. But if you have irregular columns, you can more design them using this feature. Going to shear wall, I head back to my model, unselect, and I will select just a few shear wall elements. So I zoom in, and I select this wall, and I just click on design. I'll zoom in just a little. Yeah. So I go back to my Design Plus, clicking on import, and you can see that the shear wall has been imported. Even the forces and the moments are imported. This is a very fast feature, and this will greatly reduce the engineer's time. So I just need to click on design and change the rebar reinforcement if I want to, but I keep it the same. Clicking on design will tell me whether my section is okay or not, and it will also give me the PM interaction curve for the wall as well. You can get the drawings. I go to shear wall, and since I just selected one type of section, I zoom in using the Z and the enter, and this will give me the rebar rearrangement for the shear walls which we selected. If we had, let's say, 5 or 6 sections, there would be 5 or 6 drawings with the amount of rebar and the let's say the information regarding the detailing. This is the final drawing that you need to give to the draftsman, so it also reduces the time in the drafting process. So what's left now is the footing. What I need to do is just select the base of the columns. So I'll zoom in. I'll just go to here. And by selection by window, I will just select the nodes. So these 4 nodes have been selected. I go to Design Plus, go to Footing, and then I will import them. So far what we have done is we have designed slabs, we've done columns, We have designed the various sections. What you can do is you can also do that in a tabular format in the beam table as well as the slab table here. You just, like in the member list function, you just need to enter the information and that will be done for you. This is taking some time since so this was like there's a problem maybe. I'll just check. So for the footing, we have isolated as well as pile footing design. And when the connection is completed, the design loads and the surcharge load, just need to enter the surcharge load as well as the height of the footing that you're giving. And if need be, you can check for the variation in the bearing capacity, and you can also modify the footing size. So we'll just wait. Yeah, and this has been done. So I inputted 2 types of footing sections, and these are available here. So as you can see on your screen that the design loads have been automatically inputted, and you don't need to again input them from the Excel file. So I give a surcharge load, say 20. I'm giving a less amount. So in the height I give for 1 meter. I'll change the bearing capacity, and let's say because this is not good, so what you can do is you can change the section or you can increase the bearing capacity according to the soil conditions. So also you can do that for the pile footings. Since this is just a base design, so I'm not going for pile footing. You can generate the drawings by clicking on the create, and this will give you a complete sectional. So you can see in the drawing that the curtailment of the reinforcement has been done. And you can also modify them if you want using the CAD commands. So this gives you an information regarding the reinforcement detailing, and the you can also generate the quantity for which you need, for which the amount of concrete and the amount of rebar you need for the footings. Now if you want to get a print of them, let's say for all the things that you design, you can go for batch print, go to file, and in the batch print option you can select, let's say we designed slab, column, beam, shear wall and footing, and it will give you the complete design in a printed format. So heading back to our presentation, we're nearing the end of this session. So I hope we've made it clear to you why Design Plus can be a very useful tool for you and can also contribute to the growth of your company. I would again like to emphasize on the key points of Design Plus. It was very easy and fast to use, as you've seen, and the interface was completely accessible with Midas Gen. I'll be answering your question in just a short while. So, and you can get accurate calculation results as well as the CAD drawings, and the editing functionality was also available as I showed you. And you saw how I created a Word formatted report which was complete in all aspects. And we conclude by summarizing that Midas Gen and Design Plus combined together will increase the overall productivity and will make you more efficient in all your tasks. So now I will go for the answer some of the questions that are given to me. Currently we do not have a raft or a mat foundation, we just have for footing in the isolated and the pile design, but coming up in the December version of Design Plus, we will hopefully be having those features. And slab design can also be done. I showed you that you can create for reinforcement. But as you may know that we can design slabs in Midas Gen using the meshed slab option. Regarding the currently we are already just having only the isolated file and the footing, but as I mentioned, in the December version we will be having those features. It will come up very shortly. So currently we do not have a link between Midas Design Plus and Civil, but we can also perform pre-stressed concrete, slab and beam design in Midas Gen. Yeah, you can import the no, post-tension slab cannot be designed by Midas Gen, but we can do for flat slabs. So since there are a lot of questions, I will be answering them to you by email. If you have, you can email them to me at the company, the info@midasIT.com, and as much as I can answer, I will answer them now. Yeah, we can also assign design for flat slabs. Yeah, we have a link with Revit structures for Midas Gen. You can import the structure from Revit to Gen. Yes, you can. I think you can apply. I'm not sure about this, but for this slab, you can apply line loads. I will check with my seniors and I'll get back to you on the email ID that you provided. So I thank you all for attending today's session. I thank you for taking out time from your busy schedules. And in some parts, I have also been holidays. So I'm very grateful to all of you attending today's session. And if you have any further questions, you can email them to us at info@midasuser.com. And you can also request for additional training if you want to, and we can show you the additional features. Some of them which I did not show, I can show them in the next webinar or the training session that you want to see. Yeah, you can. In Design Plus only, currently we have the American codes, but in the next version we'll be coming up with the European codes also. Yeah, you can import STAD also to Midas, as I mentioned. So some of them are very common, like can you import STAD or can you import from Revit? As I mentioned in the presentation, you can do that. We have a direct integration with Revit, Tekla, and STAD for Gen. And since some of you are requesting for workshops in your respective countries, based on the user response, if the response is good, then we can hold online sessions for you and your, let's say, colleagues. Thank you, sir. It's the trial, but some of you are also asking whether we have. So some of you are asking whether you can get the trial version of the software. Yes, you can. It is available on the website, midasuser.com. You can download from there. So it will give you almost all the functions. So thank you for attending today's session, and I hope we can conduct further sessions with you. So yes, sir, in the next upgrade, we will be including some of the suggestions that you have been giving. So in the next update, we'll be coming up with them. So thank you for your patience, and we hope you enjoyed today's session.